Decide whether the given equation defines y as a function of x, and then give the domain and range. Okay, so again, we're deciding whether the given equation defines y as a function of x. Okay, now to begin, we want to be able to determine if y is defined as a function of x. So we can do this by checking if there's more than one value of y for a given value of x. So it is probably easier to begin with the value of y and then find the value of x and then see if there's a second value of y that gives the same value for x. So, for example, okay, we have y. We're going to pick values for y. So we're going to create a table, which is y. Okay. We have x, which is equal to y squared. And then we're going to pick a value for y. Okay. So let's say if we picked y to be, let's say, -5. Okay. So if we let y be -5, then x is going to equal -5 squared, which is +25. So you want to plug in numbers to see, right? So we're picking values for y. Okay, let's pick another value for y. Let's say we're going to pick -1. So if we say x is going to equal -1 and then square it, it's going to give us +1. Okay, now if we put in, let's say, 0, okay, so x is going to equal 0 squared, which is equal to 0. Okay, now let's go to, let's say, +1. Okay, so if we say x, which is equal to 1 squared, well, that's going to equal +1. If we put in +5, x is going to equal 5 squared, which is equal to 25. So what do you see here? Okay, what you notice is that there are two x values. Okay, so you can see here that there's two x values that go to one output, and then there's also another set of x values. So what is this telling us? Is this telling us that this is a function, or is this not a function? So because of the fact that we see that we have two x values that are the same and there's more than one, then that means that this is not a function. Okay, so we're going to say no on this. All right, now before we go any further, let's take a look at the graph of this function. So I'm going to open up Desmos and I'm going to put in x, which is equal to y, and then squared. And I want to show you what this function looks like when we graph it. Okay, so here is our function. Okay, now what do you notice about this function? All right, so some of the things that we've already done in the previous examples. Okay, now in this case here, when you graph the function, it's also not passing the what? The vertical line test. So if I have a vertical line that goes through that graph, okay, what do you notice? Well, you notice that it passes through 2 points or more than 1 point. So this does not pass. Write that again. This does not pass the vertical line test. Okay, so again, that's just verifying the fact that this is not a function. Now we need to determine what is the domain of this function. So we can look at the graph, but then let's take a look here. Okay, the domain are all the x values. So remember that the domain represents all the x values in the function. Okay, every time we put a number in, it's going to square it and then make it positive. So the smallest number is 0, and it's going to keep continuing. So the domain is going to go from 0 to positive infinity. If we take a look at the graph here, right, it's the x-axis, and it's starting at 0, and it's going towards positive infinity. So therefore, this is the domain of the function. So let's go ahead and put that in there. We have bracket 0, comma, infinity with a parenthesis, and check our answer, and there is our result. Now we need to determine what is the range of this function. Okay, well, what is the range? Well, if you notice, okay, when we pick numbers for y, we can pick any number. We can pick a negative number, we can pick 0, and we can pick positive numbers. So that means we can choose any of those to define the range, because the range is all the y values. So therefore, the range is going to go from negative infinity to positive infinity. And again, if you look at the graph, right, the graph, okay, is going to be the y-axis, okay, and it's going from negative infinity to positive infinity because this graph has arrows. That means it's continuing up and then continuing down. So therefore, that is the range of this function. So we're going to go ahead and put that in there. So we have parentheses, negative infinity, comma, positive infinity with a parenthesis. Check our answer, and then there is our result.